my experience with XLR. So I was enrolled in XLR for a software testing course, and I have to say, right from the start of the course, we were provided with the best service. I feel the quality of teaching in the course is the best, with live lectures every day, separate doubt sessions, and also recorded sessions if you have missed the sessions or you just want to revise. Throughout the course, we learned manual testing, Java, SQL, Selenium, and TestNG framework. After the learning part was completed, interview preparation sessions were also conducted. So proper guidance was given by the faculty, assignments were given to be completed, and group projects were taken, as well as we had to make individual projects, which proved to be very beneficial for us in sharpening our skills as well. So mock interviews were also held to make sure we get good placements. Finally, I got placed in many companies. So as my personal experience, it's the best institute to join if your dream is to get a job in IT and make a good career in IT. So just go for it.
Hi, I'm Sai Akhil, and I'm working as a process consultant and data analyst in Siemens Technologies Private Limited. After joining XLR on my first day to the classroom, so I went there. I was really nervous because I'm entirely new to data science, and data science is like an ocean. So I felt like how would it be? How would the faculty teach me and everything? The faculty was really good. They went on about teaching things in a really specific manner. What problems would you face as a data scientist, and how would you solve it? So they explained everything in that manner. The business knowledge which XLR imparts on a student, so that's something which is really valuable. One more great thing about XLR is that there are really good value added courses which are provided to me for free without any extra fee, like Tableau, cloud engineering, and big data engineering, and some really good courses which are in demand in the market, which were to be learned along with the data science to be a good data scientist. So they gave me a Jumbo pass where they will give you all the training videos with all the training videos, and some new videos which about to come as well. So those videos I used to refer whenever I get stuck in work. It is like the bond that never ends for us and XLR. So that's a really great thing. I would definitely with it would be the best institute.
Hello all, myself Amit Kulkarni, currently working as associate consultant in Bristlecone, a Mahindra group of companies. A good thing which I see in XLR solution is that the feedback loop which runs here. So the model in XLR is such where student is not getting a one-way traffic where he is just learning and going to home. Here after the student is getting enough data to learn, he is given assignments bi-weekly or sometimes weekly. These assignments are coming up with some deadlines, like the deadlines you meet up in a industry where you work in. Those assignments come with a few set of questions and sometimes with a problem statement also. After getting a check from assignment team and mock interview results, the placement team moves our resume to the respective companies via HR. I got a call from Bristlecone company where the interview was scheduled, and the good things which I can share is that the questions which were asked were quite similar to that of what mock interview was scheduled. So after clearing 2 rounds with Bristlecone, I got selected, and currently I am working there as associate data engineer specifically, and my day-to-day work depends from varying types of tasks, from data quality to data science levels.
Hello everyone, my name is Ashish Gupta and I am a BBA graduate. So after graduation I was thinking what to do, like how to upgrade my skills and unlock my potential. Then I got to know about XLR and here I had enrolled for data analytics and data science course. So after joining the course, the teachers here are very helpful and experienced. They helped me a lot in clearing my doubts and all the topics. So after completing the course, then the assignments, the mock interview, the placement team guided me in finding the best possible job. Here, the real life projects and resume building sessions are really helpful. They helped me a lot in my interviews. Eventually, from XLR, I got placed at Triveni Enterprises, where I work as a marketing strategy analyst. So, hence, I would highly suggest XLR to students who are looking for a future in data science and data analytics. And a big thumbs up for XLR.
Hey, I'm Rashmi Sarur. I joined for the Jan 2023 Selenium course where the course covered both manual and automation training and also included live projects that helped me enhance my knowledge. Apart from training, the institute also provides pre-placement sessions and mock interviews that help me understand my weak points. They also provide placement opportunities across the country, through which I got placed at P-Test, Bangalore as test associate. I really thank the team for their efforts and their constant support. I highly recommend XLR for those who are looking for a professional course to kickstart their career. Thank you.
Hi, I am Shilpa. I am from Bangalore. I hold bachelor's degree in engineering. I had been working in non-IT field since 2013 to 2019, and later I did my course in software testing in XLR. During the training, I had a very good learning experience. The trainers were very good. We had a separate assignment sessions and we had a project sessions also. I got an opportunity to work on real-time projects, which is helping me in my career today also. I suggest everyone to go with XLR, as I am proud to say that I got an opportunity to work with, and even after having a gap of 3 years and switching my domain from non-IT to IT, I got lot of opportunities in terms of job. So thanks to XLR.
Hello, this is Sriram R. Shankar and I've been the part of XLR for an year or so. I've previously completed my Python internship, which was core Python internship, and it was actually working on core Python, which also had project deployment in Python, which included data structures and very deep knowledge of Python. Since 6 months this year, I have been the part of full stack web development course at XLR. Interestingly, after 2.5 months or so since I started my course, I also got placed into a company called Central Technologies here in Bangalore, and I've been there for like 2 months for now. The full stack web development course had a lot of parts which were taught to students, which included mainly front-end technologies, back-end technologies, and deployment using the databases. So the front-end technologies included popular and the backend included Java and Spring Boot. So the front-end technologies or back-end technologies both were taught right from the scratch. So even a student or a candidate who was from his or her non-technical background could easily was able to learn the technical stuff that was provided from XLR. Apart from this, there were online materials that were to be accessed anytime the student wanted, and we also were given live projects, assignments repeatedly. The tests were conducted from the institute, which gave me a lot of confidence in facing the interviews. Also, when I was selected from XLR, I was placed at a company called Central Technologies. I was actually posted to an ML intern post. Even later, even after getting placed, I was constantly in touch with the team, They asked me about how the work experience was, how I was feeling personally working at Sandrol. So we always had that touch with the XLR team. So I'm really grateful for the opportunity that was provided by XLR and the placement. They have been my constant support that I always wanted. Thank you, XLR.
Hello everyone, this is Vidhi Vinoj Kurup, and currently I'm working as a data analyst in Gartner INC. And I would like to be very thankful to the XLR Solutions that they provided me such a good direction throughout my journey, throughout the course. And talking about my background, like I was completely from the academicians field. I was a research scholar and I used to deliver lectures in the senior colleges. So you can understand, like I made a career switch from academics to the corporate, and it was challenging, I can say, but you should overcome it, and that's all all about our life. So I can say, like, if talking about the course in XLR, it is bit it is not bit a lot of interactive sessions you can see every day. Whatever, if you are coming out of with the doubts, the mentors are always ready, the team is always ready to answer your questions or answer your doubts. So that's a very good part of the XLR Solutions, that they are ready for for answering your doubts. Talking about the course it went around 3 to 4 months of duration, and after that we were given up with the assignments. Those assignments were really helpful because it it covered almost all the topics involved in all the sessions, like including Excel, MySQL, Power BI, Tableau. So this assignment helped us to skill up more about this all data analysis. After that, we were given up into the live projects where, like, we were asked, like me myself, I have done the 2 projects with XLR Solutions, and those projects were really helpful in my career because it gave the real time scenario, like how the work goes on in the real time business world. So to thanks once the for providing such a good guidance for me, and I would like to give a message to everyone, like nothing is impossible in this world. If I can do it, I can switch my career from academic field to the data analyst field. Why can't you all? It's everything matters.
Dear students, I hope my voice is audible and confirm in the chat, is my audible?
Yes, Sushmita, you're audible.
Yeah, thank you so much. You can start the session, sir.
Yeah. Sure. Thank you. Good evening, everyone. So yesterday we have started with the introduction and the classification. So I hope you guys enjoyed the previous lecture. And obviously, as you know, that these sessions would be more interactive, right? So obviously, I am expecting some kind of answer, some kind of feedback from you guys as well, right? Whenever I am doing or I am sharing my experience, as well as whatever the technicalities I am sharing with you. So I'm expecting some feedback from you guys as well. So let me share my screen first. So yesterday actually we have started with the HEV classifications. So 1 second. I think my screen is visible, right? Yes.
Yeah, yes, sir, it's visible.
Yeah, thank you. So basically, we will start today. We will start with the powertrain architecture. So as yesterday also we have discussed on that, what are the major component that we are using in a HEV. I am specially talking about HEV because as you know that HEV are more complex than EV. So as obviously the structure told that we have an IC engine as well as a electric motor, and we are connecting these two thing. We can say the two power source. Yes, it is nothing but a power source, or we can say the power conversion source, right? So we are connecting these two thing with a single shaft. So obviously our main motive is to run the wheel. So yesterday I told that there is an power split device, that is PSD, which basically in current industry actually we are using PSD, that is power split device. So on the right hand side you can see that there is a three types of gear actually we are using in this PSD. And from the yesterday's whatever the PSD block diagram I have shared with you guys, that the motor, generator as well as the IC engine are coupled with this PSD, right? Power split device. So there are three types of gear you can see. The we can say on the left hand side, that is named as ring gear, and which is basically connected with a motor, right? Electric motor. So most of the time whenever actually we means we have done those classifications yesterday, that is hybrid, sorry, series hybrid, parallel hybrid, also there is a series parallel hybrid. In every cases you have seen that the motor, the electric motor is directly connected to the wheel, we can say, right? Wheel shaft. So on that case, you can see that from here also in PSD also, the outer ring gear is directly connected with the motor, right? And after that, in the middle one, that is the planetary gear, or we can say this is a carrier gear, right? In this carrier gear, actually, there are four small planetary carrier actually we are using. So you will get means more pictorial format whenever actually I will share the one second. And the small one is a sun gear. So for your information, the bigger one is a ring gear, the middle one is a planetary carrier gear, and basically the planetary carrier gear is using, means we are connecting IC engine with this planetary carrier gear. And the small one, that is a sun gear. So sun gear actually we are connecting with the generator, right? So three components connected with three different gears. So on the left hand side, actually, you can see that the red one, the red denoted gear, that is the our ring gear, right? And after that, inside this, the middle one, right, which is denoted by a blue color, that is nothing but our carrier gear. And you can see that uh, the smaller one, that is denoted by green, that is our sun gear, which is connected with generator. And you can see on the top of this block diagram, that is the engine, and that is the generator, which is denoted as mg1. And that is it is basically electric motor, which is denoted in red one, that is mg2. So you can, I think you can understand that how actually we are connecting those main component with each other. So this is the internal blocks of a PSD. Now how it will work? Okay, let me share another screen. So I hope you can see my latest screen. Let me zoom out. I hope the transitions also you have means you can see the transition as well. So here basically the condition 1, that is supposed to be vehicle is stationary and the engine is on ideal condition. The vehicle, please be noted, the vehicle is stationary. One second, there is any question. Okay, let me complete this topic first. After that I will do a question answer session. So okay, the condition 1 is the vehicle is stationary and the engine is on ideal condition, right? So the vehicle, see, the electric motor is directly connected with the wheel shaft, right? And obviously it is connected through a ring gear, and ring gear is the outer gear is named as ring gear, already I told. So you can see that the vehicle is stationary, so that is why our ring gear is not moving. And you can see that the planetary carrier gear is rotating, right? As well as you can see that the small sun gear are also rotating, right? And these four gears are nothing but the planetary carrier gears, or we can say pinion gears, right? So obviously whenever actually we are starting a vehicle, right? And mainly I am talking about for HEVs, right, hybrid electric vehicles. So on that conditions, obviously we are not moving, right? And you can see that basically whenever actually suppose we need a very low speed transmission, right, very low speed transmission, or supposed to be in stationary state, so obviously your motor will be in stationary state. So this is the condition. Now let's see some. Now the second condition is the vehicle is moving forward in the forward direction, right? So you can see that at a low speed, very low speed, obviously it will be run by the electric motor, not the we can say, obviously it will be run by the electric motor, not by the IC engine. So here you can see that the outer ring gear is rotating, right? And but the planetary carrier gear, the pinion gears are moving. That is four small one, right? That is a pinion gear. Four small gear are rotating because we need to connect the generator with the motor, right? Because all the components should be connected with each other. The carrier gear, as well as the ring gear, as well as the sun gear, right? Sun gear is connected with the generator. So obviously please be noted these three gears, as well as which components, or we can say which part is connected with which gear. Now let's see the condition 3, that is the acceleration. So previous one is a vehicle is moving with a very low speed, right? Very low speed. It may be 20 to 30 kmpl, sorry, kilometer per hour. But the third one is the acceleration above 60 kilometer per hour. That means we need to connect our IC engine, as well as we have to connect our motor itself. We need both the powers. So on that case, you can see that whenever actually, see, everything is depends on your acceleration pedal, right? Whenever actually you, obviously there is a mode of selection, but yes, depending on your acceleration pedal, actually it will acknowledge, the ECU is nothing but your electronic control unit. So ECU will acknowledge that you need more extra powers. So on that case, it will actually starts the engine, as well as it will be rotating the motor, right? So on that case, the engine provides the means basically engine is rotating. So on that case, obviously the motor will also rotate, right? Because it is connected. So this is the three type of conditions where actually you can see that sometimes the ring gear is actually in stationary state. Sometimes the planetary carrier gear is in stationary state, and sometimes all the three components are moving, right? It would be IC engine, as well as the motor, as well as the generator. Now let's come to the mode of operation. So basically this is a EV mode. So EV mode means whenever actually you are supposed to be means you are in a traffic, right, and your speed is less than 20 to 30 kilometer per hour. See, it depends on the manufacturer to manufacturer, obviously. But EV mode means when there is a heavy traffic regions or very low speed transmission. In case of HEVs, I am talking about. On that case, the primary power source would be the battery pack, and IC engine would be on your off state, right? So obviously, if your battery has power, means obviously if your battery is charged, it may be 60%, 70%, 80%, right? So on that case, means on that EV mode, mostly IC engine will be on off condition or off state. Mg1, as I already told, that is a generator set. So generator set will be on inactive state. Here only main power source would be your Mg2, that is our electric traction motor, right? So basically, what is the battery usage here? So obviously it discharges through the Mg2 and give the propulsion, right? And obviously regenerative braking takes place whenever actually we are doing the deceleration. So as yesterday also I told you, there is a difference between deceleration and braking, right? So you can see the application. That means this type of EV mode application is for low speed transmission, we can say, or city driving especially. So on the right hand side, I means from the block diagram itself, you can understand that how actually it will works, right? Now let's come to the second mode, that is a cruise mode. So cruise mode, whenever actually you are applying cruise mode, on that case, the primary power source would be engine, and electric motor will assist, right? So electric motor is used for assistance only. So here our main power source is engine, and you can see that the application first, that is a moderate speed, city or highway, where the speed is nearly around supposed to be 60 kmph, right? 60 or more than 60. So on that case, how engine power split means obviously goes. So obviously engine power split will drive the wheels as well as generate electricity via generator, means Mg1, right? So on that case, as I know that means as we know that Mg1 is only used for generating the electricity. Means whenever actually we are rotating, means see, in our normal IC engine vehicles, I am talking about normal IC engine vehicles, right? It may be two-wheeler, it may be four-wheeler, it may be means any type of IC engine. So do you guys know that we used a alternator to generate the electricity? As you know guys, that there is a auxiliary battery pack also we are using in IC engine vehicles to power the auxiliary loads, supposed to be indicators, supposed to be headlights, supposed to be blowers, right? Air conditioning units in a four-wheeler, right? So this type of loads, that is comes under auxiliary loads. So this type of auxiliary loads actually powered by those auxiliary battery pack. I am talking about IC engine vehicles, not an EV. So on that case also, whenever actually we are starting the engine, on that case means on that point, actually the charging started via alternator. As you know that how alternator works, basically it is generating the electricity, right? So on that case, obviously here our main focus to use the generator set is to generate the electricity. Now main point is, whenever actually we are using this cruise mode, on that case, means if the supply is more, right? Suppose the supply is more and the demand is less. On that case, if there is a excess power is generated by Mg2, that is the generator, it can store the energy in the battery pack, means it can recharge the battery pack, right? And suppose obviously suppose your power is not means your supply is equal with demand. On that case, your means generator power will not charge the battery pack, it will actually bypass the motor, and obviously it will rotate the wheel, right? So this is the application in the moderate speed. So, and you can see that our main purpose of the generator means mg1 role is the adjust the engine speed as well. As you know, whenever actually our engine is rotating in high rpm, obviously whenever our engine speed is higher, on that case it is taking a more fuel, right? So obviously mg1 role is to adjust the engine speed and obviously generate the electricity. So this is a cruise mode, right? And it is used for city or highway driving. Now there is a overdrive mode. It is for highways, means it is for highway or high speed acceleration only. Suppose the vehicle speed is nearly suppose 100 km per hour, right? So on that case, the primary power source is engine, right? Here we are not turning on our motor, right? So how engine power split works? So obviously engine will drive the wheels as well as generate the electricity. In this case also, the main work of the generator is to generate the electricity as well as fine tune the engine rpm. See guys, this generator and the electric motor both are connected with a power electronics conditioning unit. We can say this is a controller, right? So obviously by using this generator energy, we can charge our battery pack, right? And also suppose here only our main power source is engine, right? On this overdrive mode. So on that case, obviously the mg2's role means the motor role is nothing but to assist the propulsion, right? Nothing more than that. And obviously the if you're talking about the battery usage, so we are not using the motor, right? We are not turning on the motor. So on that case, obviously it will means the battery will be, it may be charged, right? Or it may be on standstill condition. It depends on the supply and need. So here means in the cruise mode, we are using both the power sources, right? Means engine as well as the electric motor, or we can say battery. In overdrive mode, we our primary power source is engine only, not the electric motor, right? That is the basic difference between this cruise mode and the overdrive mode. And please be keep in mind that what is the application, right? High speed acceleration. Overdrive mode is only used for high speed means acceleration. Now there is one more mode actually manufacturer introduced, that is power boost mode. So in this power boost mode, we need full power of engine as well as full power of electric motor. So means here basically we want to use the battery pack as well as the fuel, right? Whatever, petrol, diesel, gasoline, whatever it is, right? So here basically our engine power split works. See, engine power split obviously working same, driving the wheels and generate the electricity via mg1. Now how means mg1 works? Obviously generate power for mg2, right? Means suppose there is a high need of current, right? Obviously if you are using an electric motor, means whenever actually we are designing this type of HEVs, our generator rating is lower than the motor rating always. I have shown you some case studies yesterday as well, right? Parallel hybrid, series parallel hybrid also. On that each cases, right? On that every cases, basically on that every cases, we have seen that the generator rating are always lower than the motor rating, right? So obviously, whenever the motor will perform on its high or peak power mode, on that case, it means generator power is not sufficient, right? So obviously, battery will be in use. So on that case, the motor take the power from the, or we can say take the energy from the battery pack itself as well as from the generator. So main three difference between these three mode is, means in cruise mode we are using both the parameter, or we can say we are using both the components, right? IC engine and electric motor, but on a very low rpm. Engine is working in very low rpm, mg2 also working in very low rpm or very low power. In the power boost mode, both are working in a full fledged, right? It both are working in a full fledged. And what is the application, guys? That is a rapid acceleration, right? Suppose you need to overtake a car, suppose you need a means speed change nearly suppose 0 to 60 or 60 to 100, and there is a rapid change. Also it can be used for climbing in a hill, right? On that case also we need a higher torque. So obviously engine is not sufficient to generate that much torque. So that is why actually we have to use IC engine power as well as the full motor power, right? So these are three modes. Now guys, you can ask question obviously, because means after that we will transfer into a different domain. So please ask some questions, means whatever you have a query on that mode of operations. Okay, someone is the battery 12 volt or 24 volt. No, see, there are in HEV, in EVs we are using two types of battery. One is auxiliary battery and one is our main high voltage battery. See, whenever actually we will be supposed to be working on the battery pack designing, on that I will share this thing why actually we are designing a high voltage battery pack, not a low voltage battery pack, right? So mostly the auxiliary battery pack is rated of nearly around 12 volt, and obviously the energy would be depending on your application. But the high voltage battery pack, that is on 20 kilowatt hour, 30 kilowatt hour, and the battery voltage is supposed to be around 240 volt, 360 volt, 480 volt, right? I will be sharing the case studies whenever actually we will cover the battery technology and the case studies, that which manufacturer like Tesla, Porsche, and BYD, which type of and which voltage batteries they are using, right? So that I will cover on the battery pack design part. Okay, there is another question. So one question is there, if we are using a generator for an IC engine, means we are actually running on IC engine with generator, wouldn't we lose some energy from friction through the gears? See guys, in HEVs, right, uh, means if suppose you are not having the generator, right, just take it as a case study. Suppose we are not having a generator, we are actually using the IC engine only. Obviously there will be a loss, right? There will be a gear loss. But if you are not using any alternator or generator, so obviously you will lose more energy, right? The generator is, see, you have to run the IC engine in a proper RPM, supposed to be 4000 RPM, 5000 RPM. So I think you guys have seen bikes, right? Bikes, four wheelers, most of the time you can see that uh, means 0 to 10,000 RPM the IC engine will rotate, right? 10,000, 12,000 maximum. So obviously, whenever we are supposed to run a IC engine to a 4000 RPM, 5000 RPM, if we are connecting a generator, it can generate energy, right? It can generate electricity. If you are not using a generator, obviously you are losing energy, right? So that is how actually we are using a generator in a IC engine based vehicle as well. In every IC engine vehicle, we are having a generator. In every, I mean, four wheeler, three wheeler, two wheeler, in every vehicle we are using generator, or we can say alternators. Okay, so your question is, would we get the same power output from the same vehicle which is non-hybrid? No, we are not getting the same power output. See, whenever we are using a IC engine based vehicle, right, on that case the generator or alternator rating is lower, right? Because we only have an auxiliary battery, a small battery pack, and only we are using those battery pack to basically turn on the auxiliary load only. Auxiliary load, right? Already I told you, blowers, means lights, indicators, horns, right? So this is very low powered loads. So on that case we don't need to use that much bulky generator. But in case of HEVs, hybrid electric vehicles, we have to use, means most of the manufacturer used 20 kilowatt, 30 kilowatt, 40 kilowatt generators. So obviously the purpose of this means purpose to use this generator is to generate electricity for the motor or to charge the high voltage battery pack, that is lithium battery pack, high voltage lithium battery pack. Okay, one of the question is, does this modes depends on gears or it has different option like city mode, sports mode? Yes, you have to select the mode of operation. Whenever suppose you are driving a HEV, on the HEV itself, see, whatever the display you are seeing on the EVs, that is named as cluster. Please be noted, cluster. So in the cluster, you have to select the mode of operation. It may be city mode, sports modes, overdrive mode. So this type, cruise mode. So this type of modes you have to select manually, right? After that, see, obviously depending on the speed, actually it will react, right? So obviously you have to select manually this type of modes. Okay, is this managed? Uh, all of the power managed by ECU? Yes, obviously all the powers is managed by the ECU. That is a power conditioning unit. Means whenever supposed to there is a generator is generating the power, we have to convert this power to a DC obviously, and we have to charge the battery pack. And this ECU will control the motor current as well, right? We have to control the motor speed also, right? We have to control the engine speed as well as the motor speed. So all this controlling part is actually done by the ECU, right? Yes, I will share all of this material after the session ended. And already I have shared with the team the yesterday materials, right? Don't be worry on that. As yesterday also I have shared with you one data, one case study, that is a Toyota Prius, right? So Toyota Prius also using PSD, right? Toyota Prius is also using PSD. So in that case, basically they are using nearly around I think 100 kilowatt of IC engine and nearly same power rated electric motor, but the generator rating is nearly around 40 kilowatt, 30 to 40 kilowatt. So obviously most of the time generator ratings are lesser than the IC engine as well as the motor, right? In case of HEVs. On high speed, how motor speed is controlled? So basically the motor, see, there is a motor controller. So obviously we will see the controller itself, that how actually we are controlling the motor, and it's also depends on the motor technology. So in a couple of couple of minutes later, actually I will show you what types of motor technology actually we are using. So most of the time, see, depending, we have to sense the means motor position. Means actually, first I have to complete the motor engineering, right? After that, it will be clear that how actually we can control the motor speed, right? Okay, there is a okay. So you are saying means okay, there is a question that is, shouldn't this be a DC motor? See guys, we can see what is the major example. Means we can say the largest example, that is we are using a DC motor. Means in case of obviously traction, means electrical traction, Means for locomotives actually we are using DC motors, right? But there is a drawback. Whenever actually we will be covering the motor technology, obviously we will see that what is the drawback of a DC motor. We are not using any DC motor, we always use AC motor in case of EVs. In case of locomotives also, nowadays we are actually replacing the DC motors. On that case, we were actually using DC series motors, but nowadays we are replacing with induction motors. In case of locomotives, I am talking about. But in case of EVs, we are actually using AC motors itself. No, we don't use any DC motors. What type of battery are used in EV? Yes, mostly lithium ion battery. Mostly lithium ion battery actually we are using. So okay, we can now. Okay, I hope you can understand the mode of operation. Okay. Okay, please tell about the LMS at the end of the session. Yes, yes, obviously, our team will discuss on this. Okay, so we have completed with the mode of operations and how actually these gears are working and how our three main components are working. So now actually, okay, so this is a parallel hybrid architecture. As in the on the screen actually you can see that the left hand side, that is the engine, and this one is nothing but a PSD. On the right hand side, the bigger one is the motor. From the size itself actually you can understand that how much big it is, right? And the generator is a smaller generator. So this is basically a we can say a HEV engine motor genset with the PSD technique. So this is the actual means engine actually we are using in HEVs. So we can see that how complex it is, right? So in case of IC engine, we are only using the IC engine itself. But in case of HEVs, we are using all the parts, right? It is a single parts, which basically holds all the three major components. Okay, there is a question that why actually we use two motors instead of we use one traction motor. Okay, it depends on your mode, right? Whenever suppose there is a no need of electric motor, right? On a we can say overdrive mode, we don't need an electric motor on that case, but we have to generate the electricity to charge the battery pack, right? We have to think on to recharge our battery pack, right? So to use this small size generator is to generate the electricity to charge the battery pack, high voltage battery pack, right? See, regenerative braking, whenever we are doing regenerative braking, on that case, we can, in case of HEVs, we can hardly achieve 5 to 10% of the lost energy, right? 5 to 10% maximum. That would be also depend on the driver, obviously, right? So the main point is to use this motor and generator set separately. On that, suppose we don't need that much power, right? On that case, your engine will be running. On that case, the generator will be moving and generating electricity to charge the high voltage battery pack. That is the main purpose to use this generator. Electrical losses. So forget about the right hand side. Only focus on the left hand side. That is a power versus power and vehicle speed. So as we know that if the vehicle speed is increasing, on that case, we have to use the motor as well as IC engine, right? Both the power we need. Now there is a case study, that is there is a rapid acceleration, that is a speed on the left hand side, sorry, on the right hand y axis, basically you can see that is speed, right? So the speed is, there is a rapid acceleration from 54 kilometer per hour to 72 kilometer per hour, right? On the right hand side y axis you can see that that is a speed in kilometer per hour. On the left hand side y axis you can see the power, right? And here you can see that the motor power, engine power, generator power, battery power, and vehicle speed. So vehicle speed is denoted by the red line. So you can see that whenever actually we need rapid acceleration, and you can see the time also, you have to note the time from 2 seconds to 6 seconds. 6 not, that is nearly 8. So within 4 seconds we have to accelerate the vehicle, means 20 km per hour more. On that immediate case you can see that the motor power is rapidly increasing. Whenever we are supposed to give the acceleration via means obviously physically to the acceleration pedal, on that immediate case you can see that the motor power is rapidly increasing from 2 seconds from this point to this point. That is rapidly increasing, as well as the battery power. Obviously the battery is basically giving the power to the motor, so obviously it is proportional, right? And you can see that the generator power and the engine power is totally opposite. You can see the means the engine power, sorry, generator power and the engine power. So you can see the engine is actually at a constant speed, not it is rapidly increasing. Why? Because if suppose the engine speed is rapidly increasing, then obviously fuel consumptions will be rapidly increasing, right? Our main motto is to use this type of modes, means rapid acceleration, on a EV mode especially. So we are actually powering, uh, means this, suppose whenever we need a higher speed, on that immediate manner we are actually activating the motor power, not the engine power, right? So you can see that the engine power is absolutely constant throughout the range, as well as the generator power, because obviously both are connected with each other. And obviously generator power is, or we can say generator RPM, rotation per minute, actually controlled, right? It is controlling the engine rotation, the RPM. So it is constant, but whenever actually there is a uh, there is a rapid acceleration from 2 seconds to 8 seconds, and after 8 seconds you can see that the speed is constant from 8 seconds to 12 seconds, right? From 8 seconds to 12 seconds the speed is constant, and you can see there is a rapid decrement in the motor power as well as the battery power, right? So now the speed is constant, so we don't need that much motor power also, right? So on that immediate case you can see the motor power and the battery power is rapidly decreases. After that we are doing deceleration, right? Please be noted, this is deceleration, not braking. So whenever the speed is decreasing from 72 kilometer per hour to 54 kilometer per hour, on this deceleration period, actually the battery is charged, and you can see that the motor actually works as a generator, right? So the motor works as a generator and it's actually regenerate the energy. On that case it is actually means negative power. Negative power means it is generating, obviously, right? Positive power means it is actually means it actually need the power, right? It is not generating. On that on this state, after 12 seconds the motor is actually generating the energy. This is called as a regenerative braking. I will show you the overall path on the regenerative braking. I will separately means sharing you those things. Okay. So I think you can understand that in rapid acceleration and in the rapid deceleration, how motor, battery, and generator works, right? As well as the engine also. So on the right hand side there is a losses, electrical losses. So obviously there is a total loss, you can see, which is denoted by a blue line, and the same, the speed, vehicle speed, is denoted in red line. I think you can understand easily. So you can see after 2 seconds, whenever actually we need rapid acceleration, on that mode, the motor power, we need more motor power, we need more battery energy. So that is why on this time span from 2 seconds to 8 seconds, you can see that the battery loss and the motor loss is more, right? After that, you can see that whenever there is a constant speed that is on 72 kilometer per hour from 8 seconds to 12 seconds, so there is a no loss, right? There is a very less loss in the battery and in the motor, and there is a very small losses in the IC engine and the generator, right? After that, whenever we are actually decelerating, on that case also there is a loss in the motor as well as the you can see that in the generator itself there is a loss, right? So this is the loss. You can see there is a battery, right? There is a battery loss during the deceleration period. Okay, let me show you one regenerative one. One second, let me share the screen again. Okay, I hope you can see this screen. Okay, so what are the losses mainly? So mainly means I will share this paper with you guys. Don't worry on that. So on the regenerative braking process, basically kinetic energy is actually used to generate the energy. So how it works? So kinetic energy, obviously there is a chassis, whatever the aerodynamics, whatever the chassis we are designing, on that roll and air resistance losses will be there. After that, there is a mechanical brake loss. Suppose you are applying some mechanical brake, obviously there is a deceleration and obviously you are applying some brake as well. On that case there will be a loss. Suppose you are not means means you are not applying any mechanical brake, on that case the losses will be minimal, right? After that, there is a transmission loss, right? After that, there is a IC engine loss. So obviously it is a vehicle, right? IC engine have their own weight, so there is a drag torque, obviously, right? After that, there is a EM loss, that is the motor. So whenever actually motor, suppose a motor has a means whenever actually we will be doing the motor technology, on that case actually we will be clarified that whenever a motor is running above its synchronous speed, on that case it will act as a generator. So on that case actually it will generate the energy, right? So on that EV as well, whenever actually we are supposed to use a EV, on that case I'm talking about pure EV. So on that case actually regenerative energy we are getting is more regenerative energy we are getting, because of the motor size is actually increased. So after that, you can see that there is a transformation losses, that is in AC to DC converter. That is nothing but a power electronics or electronics losses. And after that, it will charge the battery pack. And the battery pack also having their initial losses. Whenever there is a high current flowing through the battery also have their internal resistance. So obviously this will be covered on the battery pack designing session, means what is the internal resistance, what are the battery losses. So obviously it will be covered on that session, but the main purpose is how actually we are generating the energy from the deceleration mode. So that is the main I want to share now actually. One second. Sharing one thing. So obviously I told this one regenerative braking how working. Okay, so that is the case study on regenerative braking specially. You can see that I have taken 5 models, right? So first I have taken Toyota Prius, that is the hybrid electric vehicle, HEV. So the regain power would be maximum up to 30 kilowatt, And what is the braking efficiency? 50 to 60%. See, obviously, whenever actually we are supposed to drive a EV or HEV, so every time deceleration is not possible, right? We have to apply mechanical brake, right? It is a driver nature. Obviously, you will push the brake pedal, right? That is a mechanical brake. So that is why the braking efficiency we are taking as a 50 to 60%, right? In case of HEVs, for battery electric vehicles, right? Which we can say the pure EVs, right? On that case, this braking efficiency will be more. So obviously, the braking efficiency we can take roughly maximum up to 70%, 65 to 70%. Now you can see how much range actually we can gain. So in Toyota Prius, obviously its generator or motor size is very much lower, right? So that is why the regain energy is nothing but about 10 to 15%. Obviously depends on your braking efficiency, friction losses, aerodynamics, right? So these 2 3 cases obviously you have to consider whenever you are supposed to calculating your regenerative energy, right? So Honda Insight, you can see that the regain power is maximum 20 kilowatt, and we are roughly gaining 8 to 12% of range. In the BEVs, as the motor rating is bigger, right? In the BEVs, we are using a bigger motor because of high torque, right? High initial torque, obviously high performance we need. So on that case, actually we are using high powered or high kilowatt peak motors. So on that case, the regenerative power also we are getting more. So for Tesla Model S, we are getting 60 kilowatt, up to 60 kilowatt of the regain power. And as you can see that the braking efficiency is nearly around 65 to 75%, and we can gain up to 20% of the range. Suppose we are giving a 600 kilometer of range, so your regenerative energy can add on 150 kilometer more, right? So that is a means work of a regenerative braking. So in every EV and HEVs actually we are having this regenerative braking technology, right? Same as for Nissan Leaf, which is also a battery electric vehicle. Chevrolet Bolt, that is also a battery electric vehicle, and you can see on the right hand side that is a range gain. So most of the BEVs have a higher range gain, obviously. So that is a case study. Now, what are the factors to choose the electric motor? So as one of the student actually asked for that, we are using DC motor. For locomotives, actually, we were using DC motors for a decades, right? Means the past 4 to 5 decades, actually, we are using DC series motors. But now you can search that we are actually transforming from DC motor to AC motor, and mostly we are actually nowadays we using AC induction motors. And now I think we are also planning to do the PMSM as well. I mean, it's permanent magnet synchronous motors also. But yes, obviously it need that type of R&D infrastructure. So also the cost, also the factor. Induction motors are very cheap than BLDC and PMSM. Mean synchronous motor. So because of rare earth magnet, actually we are using. So okay, we will cover this part in the next couple of minutes. So first criteria you can see on the screen, that is efficiency priority. In case of we are actually choosing the motors depending on our application. Suppose we are having a HEV. On that case, obviously our main purpose is to high for fuel saving. Obviously, efficiency should be high for fuel savings, means IC engine should be chosen carefully. In case of BEVs, obviously we have to choose for, means obviously efficiency should be high for range extension, right? uh, Means there is a, I am talking about for electric motor choosing, right? The torque requirement in case of HEVs, we have already engine, right? So on that, suppose we are supposed to be using means overdrive, or we are using suppose rapid acceleration, right? On that case there is a need of electric motor. But yes, there is a medium torque requirement because already we have engine. But in case of BEVs, we need higher torque for instant acceleration. Also, suppose in case of BEVs also we have to climb the hill, right? On that case, we need a very high torque, very high initial torque as well. So obviously, the torque requirement would be high in case of battery electric vehicles. If we are talking about the regenerative braking, on that case, obviously needed for energy recovery in case of HEVs, right? And as in the earlier slide already you have seen that in case of HEVs, actually the brake depend on the braking efficiency, we can roughly get maximum 10% of the regenerative energy. But in case of BEVs, obviously this is very much crucial uh, to maximize the battery use, right? Means obviously depending on your motor, means depending on your motor technology, the regenerative braking energy also actually depends, right? Suppose you are using induction motor, and suppose you are using a BLDC motor or maybe permanent magnet synchronous motor. So obviously regenerative energy will be more in the BLDC and PMSM rather than induction motor. Now, if there is a cost factor, obviously whenever you are choosing a motor for HEVs, obviously that should be lower, because there is a huge cost associated with the engine. Engine is more costlier than motors, guys. So obviously the motor cost should be lower, right? In case of BEVs, obviously there should not be any cost factor in case of motor selection, because obviously we need a high performance motor, right? Which have a very high initial torque and also which can meet your acceleration requirement, right? So obviously these factors actually you have to keep in mind whenever actually we are choosing the electric motor, obviously for two different applications. Now, what are the type of motors actually used in HEVs? That is also a case study. What are the types of motors actually we are using in HEVs and BEVs? So you can see that the first one is a PMSM, right? Permanent magnet synchronous motor. And you can see that it is a very highly efficient and it has a very high torque density. Means this type of motors actually use rare earth magnets, means basically magnetic magnets actually we are using in case of rotor. So on the next slide it will be cleared what is rotor, what is stator, right? So whoever obviously in your means an electrical electronics especially, and you guys have done your machine classes, obviously you know that that in synchronous motor, in VLDC motors, we are using magnets, right? So basically, this type of PMSM are widely used. Mostly, if we are talking about for Tata, Mahindra, BYD, so everywhere actually we are using PMSM because of its highly efficiency and obviously for higher torque generation. You can see that I am taking a very means different type of examples, that is Tesla Model 3 rear motors they are using, Toyota Prius using PMSM, Nissan Leaf using PMSM. Actually there is a new motor technology actually Tesla, many companies actually introducing, means for a couple of years back, means 3 to 4 years back, they are actually introducing a new motor technology, not this one, right? So I will be sharing a very good video on that, so wait for that video. Okay, so induction motors is robust, reliable. So as in induction motor we are not using any type of rare earth magnet, so obviously the cost is very much lower, right? In case of BLDC PMSM, the mainly the magnet cost, so we can say nearly 30%, means 25 to 30% cost actually bear, means the magnet bear the cost, right? But in induction motor it is less efficient than other type of motors, we can say PMSM, BLDC, other type of motors. And I am talking about in the AC motor range only, right? And basically induction motors is widely used on battery electric vehicles only, because in HEVs actually we need a very, means obviously efficiency matters, right? Oh, the motor rating is lower, and in this lower motor rating if there is a losses, so obviously means I mean it will not act properly, right? You will not get the proper performance. So means there is a 5 to 8% we can say efficiency difference in between induction motor and the permanent magnet synchronous motor. Is nearly 8 means 5 to 8%. So obviously in a kilowatt range, guys, in a 100 kilowatt range, this means 8 to 10% is very very much crucial. For a 1 kilowatt range, yes, it can be negligible, but in a 100 kilowatt range, right, it really matters. So obviously that is why most of the time PMSMs actually we are using. Only Tesla is using induction motors, but now also they are not using induction motors. On that previous whenever actually they launched Tesla Roadster, on that case they used induction motor. After that they used many in many models actually they used induction motors, but yes, because why? Induction motors is very easy to control. For PMSM or for BLDC, actually, we need very complex control algorithm. So obviously, induction motor is very easy to control. That is why actually they choose induction motor in the earlier stages. But nowadays they are using a different technology. Means that is also depends on the PMSM, but slightly different. So obviously, I will be showing that one also. And there is a switch reluctance motor also. That is also a very new motor. But yes, switch reluctance motors actually we are not commercially used now, right? In the present, it is in research state, right? In case of HEVs and in case of commercial EVs as well. There is a okay. There is a question: which type of electric motor we should choose? See, most of the time means as per current scenario, obviously cost. See, whenever actually you will be a suppose a product developer, right? You will be developing a product. On that case, obviously you have to keep in mind two things. One is the costing, and another one is a quality, right? So two things you have to keep in mind. Depend on your application, depend on your obviously the product pricing. Obviously, you have to choose the motors. But yes, most of the time actually we choose PMSM. Most of the Indian manufacturer use PMSM. Any you can take means Tata, Mahindra, or any type of manufacturer. Means Maruti Suzuki also using nowadays PMSM. BYD also using PMSM. In Tesla also, oh no, Tesla is using different kind of motors. That is permanent magnet switch reactance motor. So that is a different technology. But yes, most of the time we are choosing PMSM. Don't worry on the material, guys. Don't worry. That will be uploaded on the portal and you will get all the materials. Don't need to worry. With the reason to shifting to electric vehicle because of pollution of IC engines, but for the preparation of batteries or destroying the batteries, we yes. Uh, See, as I yesterday also I told you means told these things that whenever actually we are supposed to manufacturing the lithium battery packs, on that case actually if suppose in an overall life cycle of a IC engine, right, in an overall life cycle of IC engine, how much carbon they emit in a EV. I am talking about from scratch to a EV, right? From scratch means from the material development stage. Suppose we are manufacturing the cells, lithium ion cells from the lithium extraction. So in an overall life, in an overall EV life, actually it will be one third, right? We actually we have seen that the EV has no we can say no emission, right? Zero emission. But whenever actually we are supposed to manufacturing the batteries, manufacturing the cells, so on that case there is a 30% carbon emit. So we can say the ratio is a one third, right? 1:3 we can say. Means nowadays I'm talking about the current industry standards, because there is a very high efficient battery packs actually we are designing nowadays, and obviously cells are also more efficient, the chemistry also more stable, the electrolyte we are using more stable. So that is why the battery efficiency we are getting nowadays is very, very high, right? So that is why actually we can actually overcome these things. So obviously to overcome these things, researchers are actually doing research on the cell chemistry especially. So whenever actually I will be covering the battery technology, I will show you that what are the new types of battery technology actually supposed to we are researching on, right, rather than lithium ion. Okay, there is a break. So you guys need break any? Okay, okay, let's continue. Uh, Type of motor use. Okay, so you can see that this type of motor, see BLDC, the last one actually we have to look onto the BLDC. It is very much efficient, but not more than PMSM. The BLDC is efficient one, but not more than PMSM, right? But yes, BLDC is means a costliest, means very much cost effective solution, right? In case of, means if suppose you need a very low performance vehicles. Low performance stands for supposed to be two wheelers. In every two wheelers you can see that they are mostly use BLDC. In e-rickshaw, right? E-rickshaw is widely available in India, right? So in e-rickshaw itself we are using BLDC. So in case of two wheelers also, in many manufacturers they use. Very, very rare manufacturers are using PMSM. Suppose they need very high torque, very high performance, you can search it for ultraviolet. Ultraviolet, they have F99 two wheeler, that is a purely racing two wheeler. You can search it on Google for ultraviolet, and you can see that they also use PMSM, because obviously for high performance, high efficiency, obviously we need PMSM, not BLDC. And also, see, that is nothing but a cost effective solution. But if we are talking about the performance, obviously PMSM would be better option. Now that one of the student asked me that why actually we are not using DC motor. So as you can see that DC motors actually use brush, right? There is a brush and commutator we are using. So these two components actually reducing the efficiency. Whenever actually we are using a DC motor, see how alternator works. Basically in the generating station, as you know, generating stations, we are using alternators. That, what is alternators? That is nothing but a AC generator. AC generator, please be noted, that is AC generator. Whenever actually we are connecting a brush and commutator with this AC generator, actually it will convert the AC to DC. So primarily actually we are generating a AC wave, right? AC. And after connecting this brush or commutator, we are getting the DC. So obviously there would be a loss. So in case of AC motors, actually we are getting nearly 90 to 95% efficiency. But in case of DC motors, due to these two components, we are getting roughly 80% efficiency, 85% efficiency. So there is a 10 to 15% gap in the efficiency. So that is why actually we are not using any type of DC motor in EVs especially. And you can see that in case of DC motors, obviously the DC motors are much bulkier than AC motors on a same power rating. Suppose we are having a 100 kilowatt DC motor and 100 kilowatt AC motor. So obviously there would be a huge weight differences, right? Because of this brush and commutator. So obviously EVs, in case of EVs application, obviously we have to mainly decrease the weight. So if we can decrease the weight, we can actually get a very good range. We can improve the range, right? So that is why actually our main focus is to get the better performance. So that is why actually we are using lightweight motor, like supposed to be induction motor and permanent magnet synchronous motor. So that is the main means we can say disadvantage of a DC motor. Now induction motors actually we are using, right? Basically how induction motor starts. Don't means don't focus on the three idiots part, right? How induction motors start. So three phase induction motors we can easily start, but single phase induction motors we need a external starter, right? So obviously for three phase induction motor we don't need any kind of starter, it can start easily. So basically, see, there is a stator and there is a rotor. The two things I am specially sharing these for the other branches. For mechanical branches also you know about it. For other branches I am talking about. So as stator is a static part and rotor is a rotating part. So obviously we need see in the stator especially you can see that in every motors there is a stator and there is a rotor, and rotor is obviously a rotating part and stator is a standstill part. Basically in the stators actually we are having coils, or we can say phase windings, whatever the single phase windings, three phase windings we are doing. So most of the time actually we are doing these windings on the stator side. So in the stator, in the picture itself you can see there is a very small slot you can see, right? And in inside this slot actually we are doing the wiring. So this is basically the stator coil. So this is a stator housing you can see. So in every type of motors, in induction motors, in BLDC, in PMSM, in switch reluctance, so every motors having this type of stator arrangement, right? So stators having slots, and obviously inside the slots we are putting the coils. Now how actually it will rotate? So obviously whenever, see, most of the time, let me clear you, means every time in AVs we are actually using a three phase motor. In every application we can say, for two wheeler, three wheeler, four wheeler, every time actually we are using. In BLDC also, maybe you can you have some confusion, right? BLDC means it will work on DC, right? I think from that name BLDC actually you may think that it is a DC motor, but obviously not. It is not a DC motor, it is a AC motor. But yes, absolutely we are not getting a proper sinusoidal waveform from this type of motors, or we are not giving a proper sinusoidal waveform to this type of motors. I will show you. Basically we are giving a trapezoidal type of means waves to energize the stator winding, right? So that is a different part. But yes, in BLDC is a three phase AC motor, right? This is also three phase AC motor. Whatever the controller actually we are using, that is usually convert the DC to a three phase AC voltage, right? So in case of induction motor, BLDC motor, PMSM, all the arrangement are nearly same. I am talking about the stator part. So whenever actually we are applying three phase rotating field, obviously, see, for electrical guys I think it is clear that in three phase, all the phases, phase R, Y, B, you can take A, B, C, these three phases are actually displaced by 120-degree, right? So I am not going into deeper on these things, like how actually 120-degree we are getting, right? All these things. But yes, whenever actually we are supposed to control a induction motor, control a DC motor, on that case, whatever the power conditioning unit we are using, or we can say ECU, right? Electronics control unit. On that control unit actually we are having such circuitries that can generate the 120-degree phase displacement. Most of the time whatever the three phase actually we are seeing on the grids, most of, means in every three phase systems actually having their means suppose RYB, these phases are displaced by 120-degree, right? Suppose one voltage is starting from 0, after 120 the B phase started, after 120 the C phase started, right? So that is the main concept. So whenever we are supposed to give this type of three phase rotating means three phase supply to this type of stator coil, on that case there is a magnetic field actually generated. So obviously we know there is a inductance inductor property, right? There is a magnetization in the stator coil. In this induction motor actually we are using the squirrel cage type rotor. So as I told earlier, that in PMSM and in the BLDC, actually we are using rare earth magnet, right? But in case of induction motor, we are not using magnet. We are roughly using a copper or aluminum bars, right? In this squirrel cage type rotor, we are actually using copper or aluminum bars. So our main purpose, what is our main purpose? To rotate the rotor, right? So obviously we know that in a magnetic field, so there is only two poles, right? One is north pole, one is south pole, right? So we have to create this north pole, south pole inside the rotor, right? So there is a stator magnetic field. Obviously it will rotate in a direction, right? It depends on your supply, right? That is another part, how actually it rotates. But whenever actually the magnetic field rotates, obviously this rotor is placed inside this magnetic field, right? This squirrel cage type rotor is actually placed in the magnetic field, as we are using copper or aluminum bars, right? Conductive bars. So on that case, there is a magnetic field generated inside the rotor also. So obviously there is a whenever the stator magnetic field is rotating, stator is fixed, but the stator magnetic field is rotating at us in a synchronous speed. Basically means, obviously it is in induction motor there would be asynchronous operation. Means what is asynchronous operation? Means whatever the magnetic field actually we are generating in the stator, right, in the static part, rotor cannot achieve that speed. So that is why actually we are talking this induction motor as a asynchronous motor, we can say, or asynchronous operation happens. So obviously it means this synchronous speed also depends on your motor structure. Like what are the stator poles, means whatever the slot, actually I named it as a slot, it is also named as a pole also. So rotor bars named as a rotor pole as well. Mainly in induction motor there is no poles in the rotors. In case of magnets, whenever actually we are using suppose rare earth magnet on the PMSM or BLDC type of motors, on that case actually we are having suppose 14 pole motors, 10 pole motors. Mainly we are talking about the magnet, the rotor. So 10 pole rotor, 8 pole rotors. So basically this depending on these rotor poles, actually the speed is varying. So obviously the formula is 120 F by P. So depending on the frequency of the rotation and the number of poles, we are getting the synchronous speed, means maximum magnetic field speed, that is. So that is how actually we are means generating the magnetic field. And obviously with the help of this magnetic field we are rotating the rotor. So obviously in the machine sessions, obviously we will get a very clear idea. But yes, for an overview, for means I am talking about for mechanical, for other guys, that is the working of an induction motor. Just we are replacing the squirrel cage rotor, these type of rotors, just replacing these rotors with a rare earth magnet, we can actually develop the PMSM and the BLDC. Both are same. PMSM or BLDC are nearly same. Only difference in the winding structure. Whatever the stator winding actually we are doing inside the stator, the difference is only in the stator structure. Nothing means everything is same, nearly same. So this is a BLDC motor. You can see that. See inside, you can see that is a stator winding. You can see that is a stator poles. Basically there is a slot. You can see, we can say this is a pole also. One pole, two pole, three pole, four pole. So this is basically we are actually named this as a pole slot. And you can see that on the right hand side actually there, this is a magnet. You can see the small magnets are actually placed inside this overall we can say the cabinet, right? So north pole, south pole, north pole, south pole. So it depends on your speed requirement, actually how much pole it should be. So whenever there is a higher number of pole, the speed will be lower, right? Means it is actually there is a inversely proportional condition, right? Speed is actually inversely proportional to the number of pole. So number of pole, if you are choosing the number of pole lower, your speed will be higher, right? So how means, obviously there is a maximum speed range. Suppose we need 10,000 rpm, right? We have to rotate our motor into 10,000 rpm. So you have to design the motor in such a way that you can get maximum 10,000 or 12,000 rpm, right? So that is a part of motor designing, right? We have to choose the motor, means the rotor pole accordingly, right? Also there is a dependency on the frequency. So basically you can see there is a PCB, that is nothing but a controller. Most of the time we use this type, a small controller, means I am talking about, see, these type of BLDC motors are only used in very low power application, 1 kilowatt, 2 kilowatt, maximum 3 kilowatt application actually we are using, especially in two wheelers and basically on the three wheelers, the e-rickshaws. So we are using this type of BLDC motors. Now whenever actually I will be showing one video, it will be clear that how means, there is in a video format, actually it will be very much clear to you also, that how actually all the types of motors actually working. So basically the main difference in the BLDC and the PMSM, in case of BLDC actually we are doing concentrated winding, and in case of PMSM actually we are doing distributed winding. So there is also a difference between concentrated winding and the distributed winding, and also stator structure, right? The main difference between these two motors, there is some stator arrangement, right? Stator winding arrangement. One is concentrated winding, one is distributed winding. So in concentrated type of winding, whenever actually the motor rotates, or basically to rotate, we need a trapezoidal type of waveform. Whenever we are using PMSM, that is using distributed winding, on that case we need a sinusoidal waveform, or we can say the back EMF. Now from the video itself actually you can get what is actually back EMF, right? Whenever suppose the motor is running, right, there is a magnet actually we are using. So by using this magnet actually there is a back electromotive force actually are developed, which actually oppose the stator supply voltage, right? So obviously we don't need, means obviously back EMF is not fruitful for our application. But in, we have to choose the motors, or we have to design the motors in such a way that the back EMF should be lower, right? That is the main point. We should have the motor technology which have a very less back EMF, right? So that is a main difference between PMSM and the BLDC. The motor, the stator difference, not the rotor difference. Most of the time we use the same magnet in both the cases, same type of magnet, and obviously same pole magnet. So generally the main difference in the stator winding. Now actually I will first I will show you one video that will be very interesting. Okay, I have to second. Just give me 1 minute. Oh, 1 second, I am sharing my screen. Uh, please give me a feedback. Okay, sorry, what I am sharing. 1 second, guys. There is an issue. Okay, I hope you can see my screen, the car view, right? And please feedback me that you are getting the video sound or not.
Motors engineers made a stunning design choice when they developed the Tesla Model 3. They abandoned the conventionally used
Are you
and
getting the
well-proven
video sound,
induction motor.
guys? Please. Okay, very good. Okay, let's see this new technology that is actually developed by Tesla just couple of years back. That is a permanent magnet synchronous motor and a switch reluctance motor. Means we are actually using both the types of motors, right? And we are actually developing a new motor technology, that is PMSRM. So let's see how actually all the motors works, as well as how actually this motors actually works. So this is a most efficient motors actually nowadays EVs industry are using. Obviously, it is very much costlier also. That is why the Tesla means cost is pretty more, right? But the performance is phenomenal. BYD also using nowadays this type of motors. Okay, let's see. Let's watch this video. See, guys, as you have seen the little bit of the video, that whenever actually we are using that squirrel cage type, means obviously we are using a aluminum or copper conductors, right? So our main purpose is to generate those copper bars or aluminum bars into a magnet. So we are actually externally we are generating the magnetic field inside the rotor. But obviously it makes sense, right? Whenever actually we are supposed to replace this with a permanent magnet, so obviously we don't need to generate the magnetic, it's already have the magnetic field, right? So that is why, means it is absolutely clear that why actually PMSM and BLDC are more efficient rather than induction motors, right? So let's watch this. Guys, the main motive, means why actually we want to reduce this back EMF. So whenever, see, obviously we know that in a magnet there is a core loss, right? There is a core loss and there is a copper loss. So copper loss obviously associated with the stator winding, where we are using conductors or wires, right? In the wires we are having resistance. So obviously depending on the current rating, there would be a I square R loss. So that would be our copper loss. And in the magnets, there is a core loss. In case of induction motor, there was also core loss, and in PMSM there is also a core loss. But in case of induction motors, we are using copper or aluminum bars, right? So there is a current flowing through the copper and aluminum bars. So depending on that copper aluminum bars resistance, there would be a rotor loss, which is pretty high than the permanent magnet synchronous motor, or we can say the permanent magnets. But in the permanent magnets there is a core loss, right? There is a eddy current loss and there is a hysteresis loss. These two type of loss actually associated with the magnetic flux. So whenever actually we are supposed to doing a very high speed rotation, so obviously the rotor is the main rotating part, so that means your magnet is also rotating. So whenever your magnet is rotating, it is generating more back EMF, and more back EMF means more losses, more core losses. So that is the main motive to develop this new technology, new motor technology, to reduce the back EMF at a higher speed. Yes, PMSM is better. It has a very high initial torque. But whenever suppose the vehicle is running in 100 kilometer per hour, 120 kilometer per hour, on that case, the rotor rotation is very much high. So on that case, it will be actually overheated, and also it would be actually a lossy component. It would act like a lossy component, right? So that is why actually we are developing this technology. Okay, let's watch. See guys, why actually we are not using only synchronous motor. So obviously means that doesn't have permanent magnets, right? Only I am talking about synchronous reluctance motor. So this type of motors doesn't have any type of magnets, right? On that case, we are also using iron bars or the steel bars, right? Generally, sorry, conductive bars, obviously that would be. So on that case, means whenever actually we are supposed to means start this type of motor, there is a very low starting torque, obviously, and also there is a torque ripples, there is a current ripples. So whenever actually we will see the back, obviously there is no back EMF, but whenever actually we will supposed to energize the stator, on that case actually we will observe a ripples, right? So that is why actually we have to means obviously add the permanent magnets on this type of cutted slots, right? So let's watch this, share overall video. Don't means it is actually available in the YouTube as well, so I will share the link with you guys. uh, One second, I have to share my screen. Okay, so there is a case study that is on BEV and HEVs, that which type of motor they are using, which type of means what is the maximum power rating of this type of motors. So basically on the first you can see that the Toyota Prius, so they are using roughly around 53 kilowatt of PMSM. Honda Accord Hybrid, that is also a HEV. They are also using 135 kilowatt of PMSM. Okay, on the right hand side there is a drivetrain. So don't be confused. That is FWD, right? That is forward wheel drive, right? Sorry, that is a basically four wheel drive. And in case of RWD, that is rear wheel, and AWD, that is a all wheel drive, right? So forward, rear, all, right? So in Tesla Model 3, you can see that they use two types of motors. On the rear side, they are using PMSM. On the front side, they are using induction motor. So this 208 kilowatt is a, we can say, this is additive power, right? As well as PMSM, as well as induction motor. In Tesla Model S, they use dual induction motor on the old model, but now actually they are using PMSM in the new models. So as I told you, Tesla started with induction motors, but they actually removed those motor technology, and they are actually obviously nowadays they are using PMSM and this new technology, that is PMSR. So the power rating of these motors, you can see that 310 kilowatt, and this is a all-wheel drive. Means two motors actually they are using for front as well as for rear, right? Two different motors actually they are using. In Nissan Leaf, that is also a BEV. Means this lower sides means cars are actually pure EVs. So Nissan Leaf, Chevrolet Bolt, they are using PMSM, and obviously both are having a forward wheel drive and roughly around 110 and 150 kilowatt of motor. So you can see that in case of BEVs, guys, the motor rating is more than 100 kilowatt, right? Most of the time 100 kilowatt, 150 kilowatt, 160 kilowatt motors actually they are using. Okay, I have to show one more video. One second. Basically, I want to show the Toyota Prius hybrid mechanism. One second, I'm just sharing those videos. Once again, guys, I'm just sharing my screen. Hold a second. Okay, so I hope you can see my screen. Let's watch this Toyota hybrid system, how actually it works.
Engine and motor. Then this system combines these with the power split device to achieve high energy efficiency. This is the Toyota hybrid system. Each unit has been developed specially for the hybrid system. For the engine, the maximum thermal efficiency has been raised and both low fuel consumption and low emissions achieved. The motor is compact and high efficiency to achieve smooth acceleration. The generator uses the engine rotation to generate electricity, which is sent to the motor and the drive batteries. It is also used as the engine starter and provides smooth engine starting. The power split device contained in the transaxle is Toyota hybrid core technology that divides the energy output from the engine between electrical generation and driving according to the driving conditions. The power control unit is the core of the hybrid system. It controls the electricity to provide appropriate amount to each unit. The drive batteries store the generated electricity and supply it to the motor to drive the vehicle. There is no need to recharge from an outside power source or to replace the batteries periodically. They also provide superior durability and heat resistance. Toyota hybrid units have the reliability made possible by years and years of design development and continuous progress. For a Toyota hybrid vehicle, when not moving, all units stop and there is no wasted energy consumption. When the vehicle starts off, the motor drives it quietly and smoothly. For driving at low speed, the motor is used to achieve low fuel consumption. During acceleration, motor drive is combined with engine drive in a rotation range with good engine efficiency to drive the vehicle powerfully, yet with low fuel consumption. The engine drives the vehicle and charges the batteries at the same time to raise the energy efficiency. During deceleration, the rotation of the tires drives the motor to generate electricity to store the power into the batteries for reuse. In this way, a Toyota hybrid vehicle runs the engine in a rotation range in which the engine has good efficiency and that matches the driving conditions and reuses energy that has been wasted until now, and achieves low fuel consumption driving. The Toyota hybrid system is advanced technology that achieves both driving fun and superior environmental performance.
So I hope guys you enjoyed this video. I also want to share one more video that is basically on the conversion, means that is not only used in HEVs, means this type of automatic transmissions actually we are using in nowadays modern vehicles as well. Second. Let me share screen once again, guys. So this is basically that means a video on how actually those gear systems actually works, planetary gears and whatever the gear system we have discussed on the starting. So let's watch this also.
A planetary gear set as a power split device, a traction inverter to control the electric motors, and a hybrid battery. Before going into details, we will first learn briefly about the operation of planetary gears. A planetary gear consists of three main components: an internal gear, a sun gear, and a planetary carrier, along with planetary pinions that rotate as a unit with the planetary carrier. By assigning input, output, and fixed roles to these three components, it is possible to increase speed, reduce speed, or reverse rotation. Step-type automatic transmissions shift gears using this function of the planetary gear set, whereas the Toyota hybrid system utilizes a different function. We will cover that later. So for now, just remember that the planetary gear set shifts using three elements. In the Toyota hybrid system, the two electric motors switch roles between generating power and producing output depending on the situation. For this reason, the electric motors are called MG, motor generator, and the two electric.
So we already have.
Let's take a look at how the hybrid system operates under various driving conditions. During acceleration from a stop, the vehicle is driven solely by the output of MG2. At this time, since the engine is off, the planetary carrier is stationary, while the planetary pinions and sun gear rotate freely. When the vehicle speed reaches a certain level, the engine starts. For engine startup, MG1 operates as a starter motor and rotates the engine via the planetary gear. When driven by the engine alone, the engine's output is transmitted to the differential gear via the planetary gear and MG2 shaft. At this time, the planetary gear functions as a continuously variable transmission, CVT, allowing the vehicle speed to change while keeping the engine speed constant. The planetary carrier is connected to the engine, the sun gear to MG1, and the internal gear to the wheel.
So basically means actually it works on CVT, right? Continuous variable transmission. So, okay, there is one question that is, please give some information about how, when bike will be implemented as EV. See, Kaushik, already we have means EV, right? Bikes, Revolt, Revolt is there, Joy e-bike is there, uh, obviously Ultraviolet is there. So there are multiple EV bikes we have in the industry. I think Hero also developed, but no, I think that is Scooty. So obviously there is a two-wheeler market is wide. Okay, roughly I have to share the CVT, how continuously variable transmissions actually works. Let me second.
Continuously Variable Transmission, or CVT. CVT is a type of an automatic transmission that is commonly utilized in passenger cars.
I hope you can see my screen.
We'll go over the CVT's design and operation using a typical example. In this case, the system incorporates two variable diameter pulleys that transmit torque and can continually change gear ratio as opposed to other types of transmissions that offer a set number of gear ratios. As a result, the CVT employs optimal gear ratios. One pulley is the driving pulley, while the other
is the driven pulley. Transmission between the pulleys is accomplished by the use of a special belt or chain. In this example, it is a steel belt made up of multiple links. Each pulley has two halves, one movable and one fixed, to adjust the gear ratio. The movable halves of the pulleys are propelled by supplying or draining oil from the chambers behind them. When the movable halves change their position, the belt travels toward the inner or outer radius of the pulleys. The gear ratio is determined by the difference in radius between the driven and driving pulleys. Thus, driven pulley is now rotating faster than the driving pulley. When the belt is reversed, the driven pulley rotates more slowly than the driving pulley. Proper functioning necessitates synchronized movements of the movable halves in order for the belt to stay consistently tensioned and not slip. The reverse gear requires a separate mechanism. Typically, a planetary gear is utilized for this purpose. It has one forward gear and one reverse gear.
So guys, that is basically the CVT, how basically the CVT works, continuous variable transmission. So most of the EVs, HEVs, actually we are using the same CVT system, right? Whichever the mode actually we are choosing, depending on that mode, actually it will act. So in case of IC engine based vehicle also, we are having the same CVT, means in automatic cars. You already know that in the market there is widely available the automatic cars, means like scooty, right? So the cars actually using CVTs, continuous variable transmission. Okay guys, is there any question on this? Any type of questions like motor? Already we have covered a lot of things today. The motor technology, the other parts, that which type of motors we should use. Yes, planetary gear system also used in EV. No, E means, see, CVT also we are using, planetary gears. Planetary gear actually we are using also. In case of HEVs actually we are using. We are not using in EVs. Planetary is only used for IC engine based vehicles, right? So in HEV there is a IC engine, and in obviously normal IC engine, obviously using planetary gears. Okay, is there any question further? Okay, you're talking about the video. I will share the video link with you guys. You can easily get it, means many times, right? So I will share this video link with you, no issue. It is widely available in the internet. What is the best EV car for traveling? Oh my god, it is actually depends on your application. Means you need the performance, you need speed, you need looks, you need range. Actually depends on you. But yes, Indian players are doing well. I can say that they are doing well. But yes, uh, as of my opinion, the battery technology is absolutely means in the developing stage. I am not means talking that it is developed. So it is under developing stage. Obviously in futures we will more improve the battery technology as well as motor technology. So obviously that will help you. But yes, it is very means tough to be supposed to tell that which EV is best. But yes, obviously as a performance wise, obviously BYD is doing a very good job. BYD. Okay, so there is a question that what can be the reason for EV bike caught fire? The main reason is the battery technology. I will share in the next session. Whenever actually we have two sessions on battery technology, and it is very crucial sessions. So in the battery technology itself, I will cover that why actually we have seen more fire cases in two wheelers, especially. Can we create high power EV that fully depends on electric motor? Yes, fully electric vehicle we developed already. We don't need to focus on HEV only. We already have EV, pure electric vehicles. So obviously there is a high power EVs we are using in the market as well. That is fully depends on electric motor. Ayush, that is fully depends on electric motor. We don't need any IC engines for that. I hope you cleared. Okay, any other question? Okay, so there is no question. Okay, guys, then I am concluding the session. Hope you enjoyed the session. Okay, why are lead acid batteries not used in EV? That will be also I covered in the battery technology. There is a huge difference in between lead acid and the lithium ion technology. So obviously I am giving you a little hint, right? It is very less efficient and it has a very higher weight ratios. So that is two small things I just told you today. But yes, tomorrow I will be means obviously I will clear all those doubts, especially on battery technology. Okay, Ankur is saying about hydrogen technology. So already I have told you that is hydrogen technology, fuel cell. That is fuel cell technology. So means in fuel cell technology, as yesterday I told that it is not that much reliable now. The basically the hydrogen production, hydrogen storage is pretty much critical. So that is why actually and also if we compare with FCEV, means hydrogen technology, with pure electric vehicles, obviously the efficiency is very less in FCEVs as compared to IC engine based vehicles. Yes, we can get a better efficiency, but the costing of a FCEV is very higher. So obviously, whenever you are a product developer and suppose you are a OEM, so you have to keep in mind the cost also, right? So that is why, at per current scenario, hydrogen technology is not that much reliable if we compare the performance with cost. By manufacturing the battery cause CO2 emission more. Yes, whenever actually we are manufacturing the cells, especially on the lithium battery pack, and also extraction the lithiums, right, from mining, on that case CO2 emissions is more, but not more than means IC engines actually emitting the carbon in their overall lifetime. What can I do? We do for excess heat of the battery. See, there will be a separate class session on the thermal management of the battery pack. Don't be worry on that. I will be taking care of that part as well. How to get portal? Okay, so that will be cleared by Amar. Which is more reliable for long-term usage, HEV or BEV? See, guys, for HEV is a long-term usable, but for BEVs, actually, manufacturer are giving warranty for 8 years, 6 years, 7 years. But yes, means battery performance is degrading. In 3-4 years, actually, battery performance degrading. So, as per current scenario, you can obviously invest on HEVs. Any update on silicon carbon battery in on vehicle? No, silicon carbon actually we are introducing in basically smartphones, right? So for the vehicle on a large scale manufacturing, it has not developed yet. Obviously research is going on that, but yes, it can be developed. Okay, okay, guys. So there is no technical questions yet. So I am concluding my class. Amar, are you there?
Yes, I'm there.
So basically, there is some doubts on the portal, I think. So
Mm-hmm.
most of the actually they are questioning on that how to get the portal access and other things.
Mm-hmm. Okay.
So
Yeah, sure. I will take up that. So, dear student, yesterday we explained about the LMS portal. So we can report the day one YouTube video. You will get that on LMS portal, how you're able to access that. On top of it, as I said that if you face any difficulty, our support team is there available onto the mail edl@xlar.com. So I'm sharing that mail ID here into the chat box. You can just note it down and put your query about the portal or anything else. You can directly drop an email mentioning entire details. Details means be like you will drop an email. I'm not able to access the LMS, but this is the not right way. Okay, so you can mention the course name when you registered, all these things properly. Okay, and our team will sort the issue. Uh, then one more thing. So I already shared the attendance complete back form into the chat box of the Zoom and YouTube. So please make sure you are submitting your attendance and sharing your valuable feedback about the session. YouTube participant, don't forget to subscribe to this channel and please hit a like button if you're really enjoying the sessions. So on this note, we'll wind up today's session. Thank you, sir, for valuable session. And dear students, we'll see you tomorrow sharp at 7 o'clock. Till the time, take care of yourself, take care of your family, and happy learning with Explore. Bye bye. Have a nice time ahead. Thank you, nice sir.
thank you so much, guys. Thank you so much.